Okay, so now I'll be showing you guys how to configure a timer on the STM32 IDE using QMX. So for this timer application, we want a timer that will actually count how many microseconds have actually elapsed. So we'd actually want to create a delay timer for to be specific. So I will show you how to create a delay timer, then maybe a timer that will. Okay, but for this tutorial, I'll just show you how to create a timer which will count up every microsecond. Okay, so let's see which timer we are going to use. Okay, this one is mostly for pulse width modulation purposes. Usually the best timer is a timer 1, which is currently unavailable. But let's just use it anyway. So we'll be using preset mode, trigger source, okay? And then we'll be using internal trigger source 0, okay? And then the clock source is going to be internal clock as well. Okay, so yeah, like I was saying, it's usually specialized for pulse width modulation purposes, these timers, but we can still use them for our basic counting purposes. So this one is a 16-bit prescaler. Okay. And then the counter period is the maximum value that it will count up to. So it's a 32-bit value. Then internal clock division. So okay, you can leave with no division. And then the auto reload. Auto reload, you want to enable this one in the slave mode controller. Okay. So before we set our clock for the timer, or the prescaler to be specific, we want to know what frequency we're using. We're using 80 megahertz. So if we wanted to count like every 1 microsecond, we need to divide 80 megahertz by 80 minus 1. We'll get, I think the minus 1 is like for error corrections. Okay. So if you divide 80 to 3 divided by, okay, let's just take the perfect scenario. You get a 1 megahertz clock. So this will be the clock which will be going to the timer. And then that 1 megahertz clock will obviously create a period of 1 microsecond. Okay, that is the logic. But it should be minus 1 actually. So 80 minus 1 is 79. Okay. So if you use a prescaler of 79, then you can use it in conjunction with the internal clock division, but we're not going to be using that one. We're just going to use a prescaler. So now we have set up our timer to count up every 1 microsecond in auto reload. This is the most important thing. You need to enable auto reload so that when it overflows, it starts all over from the beginning again without triggering any interrupt. I'm not going to be using any interrupt for this timer. Okay, so let me just go on and configure the next timer to be an interrupt timer actually. So let me use timer 10. Doesn't have a lot of, they all do. It's a very capable microcontroller. Okay, so now we're going to enable timer 10. So we're going to use an interrupt for this one. So usually the interrupt use it for the same purposes as the previous timer that we've just configured it. People generally would use it to like count between, yeah, so to create a millisecond timer or a microsecond timer. But this is the way that I found it to be actually more effective. So let me just show you guys how you go about creating like a microsecond delay and millisecond delay and a microsecond counter using just the timer. Okay, so now let's go to our source folder. Okay. Okay, so now I think this is the time I would actually want to create a specific driver for operating the timer actually, instead of putting all the code inside the app. So let me create a driver called timer. Okay, then we can create a source file, driver.source. So sorry, driver timer driver the timer underscore time. Then I'll create the header file. Okay. Okay, so now generally the thing is you microsecond timer you actually want it to be running all the time, because actually starting the timer, like invoking the timer to start before you trigger like a 10 micro or maybe 100 microsecond delay will actually create a less more accurate. So you actually want to reduce the amount of instructions that are required to invoke the delay. So what would happen is we just allow the timer to just continue going and continue counting up and resetting. Okay, so let me exit. All right. Then here. Okay, I see what the problem is. I'm trying to make this driver timer.c. Okay. Let me just delete this file and create it again. I like the comments, so not just like the default C template for the source file. So it should be driver timer.c. Okay. So then we would include our driver first. Then include the main. Okay. So the first thing that we would do is would say initialize the timer initialize. So the one thing we would be doing in here is just starting the timer, because if you look at the generated code for the timer, it's only configures the timer and it doesn't start the timer actually, just it configures it. And okay, and then now we will so basically what we'll be doing is starting the timer actually. So to start the timer, we invoked halt. Okay, we need to include this timer as well. We need to include the header file, so we get access to this halt timer 2 structure. Okay, so to start the timer now, we so it should be hard start timer. We now have to look for it. It cannot show me the outline. Okay. Okay, yeah, this is the function to start the timer. Okay, so now since it's going to be hard to look for the functions from this outliner because it cannot do its job, let me pause the video and just look for the functions, and then I will continue. Alright, so I've just decided to pull the functions from an older timer driver that actually wrote a while ago actually. So this is basically what it does. This one starts the timer. And then now to actually okay, now to get okay, so now to let me just copy all of these functions to make it actually easier, and then I'll explain what is actually happening. Okay, So okay, so we call this function timer reset. So sometimes the countdown, the timer might be close to overflowing, and then if you want to like get a value from the timer, it will actually like become difficult because the next time it was maybe the next time you want to get the next value to get the time that is elapsed between two intervals, it's to be starting from zero. So it will be important to have the ability to want to reset the time actually. So usually use this macro definition and where you set the counter value. So the timer that we are using is timer 2. Timer 2. How timer 2? So let me verify if it takes a pointer or yeah. Yeah, it takes a pointer. How timer 2. And then now if you like want to get the amount of microseconds that have elapsed since you reset since you reset the timer, you would use this function and timer 2. So like if you want to count how many microseconds have elapsed between while executing a particular function, first invoke timer reset microseconds, and then timer get. Then after that you get the amount of microseconds that have elapsed. And then this is your delay, microsecond delay. Yeah? So we get the starting counter value. Okay. Get the starting counter value, hold timer 2, and then you wait for the for the for the counter value to or for the difference between the start and the current counter value to be greater than the delay, which is called microseconds. Okay. And then finally, you can also create a millisecond delay for using this microsecond timer as well. I'll timer 2. And okay. And so yeah, so this is basically the timer that we have. Okay. So you might ask, since you already have like a hard delay microsecond function, what would be used for a secondary delay function? Okay. I've actually had to use this while I was doing some multi-threading because you cannot use the same delay function from like 2 or 3 different threads. You like have to create a delay function for each thread. So basically, eventually, when you start doing multi-threading, you will come across a situation where you want to have your own like delay. Okay, so let me put these functions here so we can access them from another source file. All right, so then from our app source file, we will include our driver or a timer driver. Then inside the initialize, app initialize, we initialize our timer. Okay, so for interest sake, we will be using our millisecond delay just to demonstrate what is happening actually. And then yeah, so this is basically how you configure and use a timer inside the IDE. How timer get to the micro. These are the macros we use inside this header file, how timer drive. There's the one to use to like reset the counter value, set the counter value. So we're not using an interrupt for these delays, and I believe it's the best way of using this timers.